तो हमें इस क्वेश्चन में क्या दिया गया है, हमें एक मीडियम दिया गया है जिसका अगर हम प्रेशर चेंज करते हैं 1.01 इंटू 10⁵ पास्कल से 1.165 इंटू 10⁵ पास्कल को, यानी कि ये पहला वाला कुछ प्रेशर था और दूसरी टाइम में कुछ और प्रेशर हो गया, तो इसी वजह से कुछ वॉल्यूम में चेंजेस हुआ, उस मीडियम के वॉल्यूम में कुछ चेंजेस हुआ और वो चेंजेस जो था वो 10% था और यहाँ पे टेम्परेचर था वो कांस्टेंट रहा। तो हमें यहाँ पे निकालना है तो उस मीडियम का बल्क मॉड्यूलस कितना होगा। तो वो करने के लिए पहले हम गिवन डेटा को यहाँ पे लिख लेते हैं। P1 यानी कि P1 लिख लेते हैं। P1 इज इक्वल टू यानी कि पहला प्रेशर जो था 1.01 इंटू 10⁵ पास्कल, और यहाँ से P2 जो आएगा, P2 यानी कि दूसरे टाइम में जो प्रेशर था 1.165 इंटू 10⁵ पास्कल। तो इसकी वजह से हमारे पास जो प्रेशर चेंज आया, प्रेशर चेंज को हम लिख लेते हैं डेल्टा पी। डेल्टा पी इज इक्वल टू P2 माइनस P1। अब इसके बाद हमें जो वॉल्यूम चेंज का परसेंटेज दिया गया है, यानी कि डेल्टा V अपॉन V इंटू 100 इज इक्वल टू -10। अब यहाँ पे माइनस साइन क्यों? माइनस साइन इसलिए क्योंकि डेल्टा V यानी कि डेल्टा V हमारा नेगेटिव है। डेल्टा V नेगेटिव क्यों है? क्योंकि फाइनल वॉल्यूम जो है वो इनिशियल वॉल्यूम से कम हो रहा है। तो क्योंकि प्रेशर हम बढ़ा रहे हैं तो वॉल्यूम कम होगा, तो इसलिए डेल्टा V नेगेटिव होगा। इसलिए हमने यहाँ पे जो वॉल्यूम चेंज परसेंटेज लिखा है वो -10 में आया है। -10 में हमारा डेल्टा V अपॉन V इंटू 100 हमारा -10 आएगा। तो अब हमें निकालना है यहाँ पे बल्क मॉड्यूलस, यानी कि B इज इक्वल टू वॉट। अब हमें बल्क मॉड्यूलस का सिंपल फॉर्मूला हमें पता है कि B इज इक्वल टू माइनस ऑफ डेल्टा P, यानी कि चेंज इन प्रेशर अपॉन डेल्टा V अपॉन V, यानी कि चेंज इन प्रेशर अपॉन वॉल्यूमेट्रिक स्ट्रेन। अब हमें डेल्टा P और डेल्टा V अपॉन V का दोनों का वैल्यू हमें पता है, तो हम दोनों वैल्यू को यहाँ से यहाँ पे पुट करेंगे और इसके वैल्यू को यहाँ से यहाँ पे पुट करेंगे और उसके बाद हमें बल्क मॉड्यूलस का वैल्यू मिल जाएगा। तो चलो हम पुट करते हैं। B इज इक्वल टू माइनस ऑफ डेल्टा P हमारे पास क्या होगा 1.165 माइनस 1.01 इंटू 10⁵ हमारा कॉमन बाहर आ गया। यहाँ पे हम P2 माइनस P1 कर रहे हैं, ये हमारा P2 हो गया और ये हमारा P1 हो गया। तो ये क्या होगा, ये टोटल अपॉन डेल्टा V अपॉन V। अब क्योंकि डेल्टा V अपॉन V इंटू 100 हमारा -10 है, तो डेल्टा V अपॉन V हमारा क्या होगा -10 अपॉन 100। तो इसको अगर हम कैलकुलेट करते हैं तो हमारा सिंपली आंसर आ जाएगा यहाँ से 1.55 इंटू 10⁵ पास्कल। अब इस आंसर को हम मैच करते हैं इन चारों ऑप्शन में से, तो यहाँ से हमें चारों में से कौन सा आंसर मैच कर रहा है, तो हमारा आंसर डी हमारा करेक्ट है।
Well, hello students, now we're going to see this question. The question says that a given quantity of ideal gas, a pressure P, okay, and absolute temperature T, the isothermal bulk modulus of the gas is. So basically, if you think for a while, that isothermal bulk modulus is basically the time when temperature is constant. Okay, this is a process where temperature is constant. So basically this is given by the ratio of volumetric stress upon, and basically ratio of volumetric stress and volumetric strain. Okay, so this, what do I mean by this? Basically it will be volumetric, means basically bulk modulus, let's suppose it's beta, so beta is equal to volumetric stress divided by volumetric strain. So we come out to a formula, that is by putting everything in this, basically we get a formula for this basically bulk modulus in isothermal process. Isothermal Okay, we get the formula that delta P divided by delta V. Okay, I'm writing it in different things so that you don't get confused. Delta P divided by delta V divided by del V. Okay, this is basically one single quantity. So basically this is the bulk's modulus. Okay, so now firstly from ideal gas equation we know that PV equals to constant. Why it is constant? Basically for isothermal process. Why for isothermal process is it is basically constant? I'm explaining you in brief that basically from ideal gas equation we have PV equals nRT. Okay, so if n is a constant, we know R is a constant and basically T is a constant over here because it is a isothermal process, so T is constant. Okay, so this is why this whole quantity becomes constant. That means this equality, due to this equality, PV is also constant. Okay, so I explained you in brief so that you don't get confused. So now what we're going to do, we are going to differentiate it. Okay, so by differentiating it, what we'll get? We'll get D. Basically first we'll put P constant, then we'll put V constant. So P dV by D. Yeah, let's suppose we do it with respect to temperature. Okay, dt. Okay, time, let's suppose we do it with time. It will not matter at all. Okay, because we will just cancel it right now. I'll show you why it will not matter. So v dp divided by dt. Okay, and this is a constant basically, so a differentiation of a constant. Okay, I'm writing constant for now by dt. Okay, so if you see properly, what you see that dt's will get cancelled. Okay, so if you see, it didn't matter in which basically quantity you were doing the differentiation. So what you will get over here, p dv plus v dp will be equal to d of constant is basically what it's basically 0. Okay, it doesn't matter. So now what we'll do, firstly one thing is there, you cannot means cancel it, right over here. You have to do one thing, that you take dt over here firstly. Okay, and this will come 0, and basically this will also be divided by dt. So you bring this dt over here and basically it will become 0. Okay, you will bring this dt to the right hand side and it will become 0. Okay, so cancelling would have created a little problem. So what we'll do, basically we will be left with p dv plus v dp is equal to 0. Okay, this is what we're left with. So now what we're going to do, we are going to place this that side. Okay, p dv is equal to minus v dp. Okay, so what we'll have basically over here, so now we put p is equal to minus v dp divided by dv. Okay, this is what we're going to get. So if we basically if we see over here, so what we get basically from here, we'll get minus v. If we put dp as delta p, okay, it doesn't matter, so we'll put dp as delta p and dv as delta v divided by v. If we put this v in denominator, we'll get this will be basically equal to p. So what is this quantity? Basically this quantity is basically this, basically, okay, this one. Okay, so basically over here you can see B means bulk's modulus was equal to that. So hence we found out that the bulk's modulus is equal to P. So our answer will be the bulk's modulus is equal to P. Okay, this is basically our answer. Got it? So our answer is option number B. Thank you.
क्वेश्चन में कह रखा है कि इन दी प्लॉटिंग स्ट्रेस वर्सेस स्ट्रेन कर्व फॉर द टू मटेरियल्स पी एंड क्यू, एक स्टूडेंट ने इनकरेक्ट प्लॉट कर्व कर दिया, जिसमें क्या करा उसने कि वाई एक्सिस पे स्ट्रेस प्लॉट किया और एक्स एक्सिस पे स्ट्रेन प्लॉट किया. तो हमें चूज द करेक्ट स्टेटमेंट चुनने हैं. तो सबसे पहले हमें दिख रहा है कि जो स्लोप है पॉइंट पी का वो स्लोप ऑफ पॉइंट क्यू से ज़्यादा है. तो स्लोप ऑफ मटेरियल पी इज़ मोर देन स्लोप ऑफ मटेरियल क्यू. तो स्लोप ज़्यादा है. स्लोप जो इस केस में हमें क्या दे रहा है कि स्लोप जो है वो स्ट्रेन बाय स्ट्रेस दे रहा है, यानी जो स्ट्रेन है पी मटेरियल में वो ज़्यादा है एज कंपेरेटिव टू स्लोप इन क्यू. तो स्ट्रेन जो है वो ज़्यादा होने की वजह से जो पी है वो क्यू से ज़्यादा टेंसाइल होगा. टेंसाइल है तो ज़्यादा डक्टाइल भी होगा. अब जो डक्टिलिटी होती है मटेरियल की वो इन्वर्सली प्रोपोर्शनल टू ब्रिटलनेस. तो पी जो है वो क्यू से लेस डक्टाइल है. तो यानी ऑप्शन ए करेक्ट हो गया, ऑप्शन बी करेक्ट हो गया, ऑप्शन सी इनकरेक्ट. और ऑप्शन डी में ये कह रखा है कि जो यंग मॉडुलस है पी का वो क्यू से ज़्यादा है। यंग मॉडुलस की जो वैल्यू होती है वो होती है स्ट्रेस बाय स्ट्रेन। तो पॉइंट पी के लिए यंग मॉडुलस की वैल्यू कम है बी से, तो ऑप्शन डी इज इनकरेक्ट। तो ऑप्शन आंसर कौन से हो गए हमारे, ए एंड ऑप्शन बी।
Hello students, today our question is a uniform rod of length L and density rho is being pulled along a smooth floor with horizontal acceleration alpha and the magnitude of the stress at the transverse cross section through the midpoint of the rod is, so this is L and this is alpha here. So the solution of this question is we have to find the stress here. So the solution, mass of half rod 1/2 rod is equals to is mass of half rod here, and we have mass of 1/2 is density into volume. So we know that volume can be written as area into length, where A is the area and L is the length. A is area and L is length, and we have the this is equals to mass of half is equals to, so we can write here, so m of 1/2 is equals to density into area, and here length will be half, so this is L/2 here. So the force acting on the cross section, force F is equals to on the cross section through the midpoint of rod is m 1/2 into force is equals to mass into acceleration, so this is A, and we can write here this is density A into length, and this is divided by 2, and this is A here. So from this we can write here this is our force, and we know that stress is equals to, we have to calculate the stress here. So stress is force divided by area, so this is equals to density A into L divided by 2 into A, and area is A here, area is A, so therefore we can write here this is A here, so the stress will become here area, and area will be cancel out here, this and this will be cancel out, so we get density into length divided by 2 into area, so this is the stress here. Thank you.
Hello, the question here is a solid sphere of radius r made of a material of Buck modulus k is surrounded by a liquid in a cylindrical container. A massless piston of area A floats on the surface of the liquid. When a mass m is placed on the piston to compress the liquid, the fractional change in the radius of the sphere del r by r is. So, Buck modulus we know is equals to minus del p by del v by v. This is the Buck modulus, where del P is a change in pressure, del V is a change in volume, and V is the original volume. So, again, we can write where del P we can write as mg by A. Therefore, again, K will be equals to minus mg by A into 1 by del V by V. So, from here we can write del V by V is equals to minus of mg by ak, or we can shift this one to this side, negative side, for our convenience. Now del V is change in volume, so we can write V final volume minus initial volume by, this is the initial volume only, equals to mg by ak. This again we can write as Vi minus Vf by Vi equals to mg by ak. So volume Vi, initial volume, is 4 by 3 pi r cube minus final volume will be 4 by 3 pi. R is a radius, initial radius, and the final radius is r minus the change in radius we know, del r whole cube, by 4 by 3 pi r cube, that is equals to mg by ak. Now solve this. So after solving this, you will get the relation del r by r equals to mg by 3ak. So this is our required answer. That is a fractional change in radius of the sphere is mg by 3ak, which is where the second option matches with your answer. I hope you like my video. Thank you.
Hello. The question says, in Searle's experiment, which is used to find Young's modulus of elasticity, the diameter of the experimental wire is capital D equals to 0.05 centimeter, measured by a scale of least count 0.001 centimeter, and length is L equals to 110 centimeter, measured by a scale of least count 0.1 centimeter, and weight of 50 Newton causes an extension of x equals to 0.125 centimeter, measured by a micrometer of least count 0.001 centimeter. We are asked to find the maximum possible error in the values of Young's modulus. Screw gauge and meter scale are free of any error. So let's first write the equation of Young's modulus. So Young's modulus equation is y is equals to force times length upon area of the wire. Here area of the wire will be pi r square, or since r is since d is given, so it will be pi d square by 4 times the extension, which is in this case x. Okay, so this is the formula for Young's modulus. Now if we put the values here, then we can calculate the value of Young's modulus for the wire, or of the wire. So here force is given to us is 50 Newton times the length given to us is 110 centimeter. Let's convert it into meter. This will be 10 to the power minus 2 upon, in the base we have pi times d square. So d basically here is 0.05 times 10 to the power minus 2 square upon 4 times x. The given length of x, the given extension x is 0.125 centimeter. If we convert it into meter, then we have to multiply 10 to the power minus 2. Now here 10 to the power minus 2 and 10 to the power minus 2 will get cancelled. So upon simplification, we will get the Young's modulus y. The Young's modulus y we can find as, Young's modulus y will be 2.24 times 10 to the power 11 Newton per meter square. So this is the value of Young's modulus that we will find. But we are not asked about the Young's modulus, but we are asked about the error while calculation of the maximum possible error while calculation of the Young's modulus. The maximum possible error is, now first look at the formula. Here according to question, the variables in this in this formula are the length, the extension, and the diameter. So we can write the relative error in Young's modulus del y by y equals to 2 times del d by d plus del x by x plus del y by del L by L. Now let's see what will be the values of this del d, del x and del y. Now you see, del d is the maximum possible error associated while calculating the diameter. Now the diameter is calculated using an instrument or using a screw gauge whose least count is 0.001 centimeter. Therefore, del d in this case will be 0.001 centimeter upon d. The value of d is 0.05 centimeter. Whether you put meter or centimeter, it does not matter because anyway it will get cancelled. So next we have del x. Now the extension is measured by a micrometer of least count 0.001 centimeter, and the measured extension is 0.125 centimeter plus. Now the length is measured by using a scale, a meter scale of least count 0.1. So here the value of del L will be 0.1 upon 110. Now this on simplification will give 0.04 0.0489. So this is the value of del y by y. That is, from here if we want to calculate the maximum possible error associated with Young's modulus, then that is del y will be this value 0.0489 times Young's modulus. The Young's modulus, which we have found earlier as 2.24 times 10 to the power 11 Newton per meter square. Hence the maximum possible error of Young's modulus, of calculating Young's modulus, is nothing but 1.09 times 10 raised to the power 10 Newton meter square. This is our final answer. Thank you.